the last 2 days, I've not been recording. I keep forgetting to record. So can you say like, Javen, you're not recording this? Is that cool? And like, you guys help me too. Jamie, you recording this? Okay, so I will tell you this, that in the history of doing this, I've done this since 2005. Okay, so I don't, because like, so back in the day, so when I'm off camera here, I'll tell you a little bit more about this story about my bookshelf. Just remind me at the end of the period, I'll tell you about my bookshelf. Okay, but so there used to be windows like doors with the glass on them. So like this, all of this looks exactly like that over there. But like kids couldn't like get the books out, right? You know, so I like took those off, right? It makes a heck of a lot more sense if you're going to go get books off the bookshelf so you don't have to open up the cabinet, right? So when I first started doing this, I would hang the socks up like on those windows, and then like the kids that were sitting over there were like, can you please stop doing that? Like every day after class, I have the worst headache because of the fumes, because of like this, right? So this is like right in this kid's face, and you know, like, and I would hang them up like the day, you know, you'd bring them in, and it made my class like super stinky. What's that mean? I call it Flip Flop Friday.
I like it.
Thanks. Okay, so you, how many miles do you think that you drove?
Probably only like maybe one.
Okay, you, how about you? Yeah. 19. Jacob, you get, like, in the history of me doing this since like 2005, no one has ever like forgotten and like driven that far. So like, I'm like really stoked about that though, man. No, don't be sorry. It's amazing. It's amazing. So the whole point, and you guys can come back and look at these later, but the whole point of this is that once again, we are looking at the particles that come out of your car. We're talking about environmental indicators. We talked about the fact that, you know, population is growing. We talked about climate change. And so one of the key things that's coming out of your car is, yes, cars do produce, you know, carbon, but like there's all kinds of other crap too. And there's like particulates and that thing. So this is not a very scientific thing. Oh, where did my Zoom go? Maggie, are you still there? Okay,
Yeah.
all right. Sorry, it was weird. Like it just, I don't know, I'm moving around too much. All right, so, but I love it for the visual aspect, right? I hope that you, when you look at this, you're like, man, I never realized like stuff that would, like that would come out of my car, right? And so, I gotta figure out how to do this so it's like stays. All right. There we go, that's pretty good. All right, everybody open up. Yesterday we were doing the Earths thing. Okay, so, and thanks again for the Zillow, man. I thought about that last night. I was like, man, from now on I'm using Zillow. Okay, because that was like super easy. And I want to talk about how many Earths you are consuming.
Oh, mine was 3.3.
Okay, cool.
No, mine was more
Yeah,
than that.
I'm gonna start saying,
Mine
you know,
was 4.4.
thanks for destroying the Earth.
Mine
Uh,
was 4.4.
So we call this an ecological footprint, and we do have, there is a footprint. You cannot be alive and not consume resources. I mean, you have to eat, you have to breathe, okay? And so, but how many resources do you ultimately consume? We're talking about, you know, on this slide, I know you can't see this, but it says energy, settlements, timber and paper, food and fibers, seafood, all these things. Okay, where's that coming from? Carbon, land, forest, crops, fisheries, all part of that ecological footprint. Yesterday after school, Hannah was like, hey, can we just stay after school? I got to prepare some stuff. And I was like, sure, let's hang. And I got an email from like I'm on the email list for the place that does the ecological footprint. Okay. And I usually ignore them. Okay. Yeah, bless your heart. And but I opened it up because I thought, oh, we just did this, and they released a new graphic yesterday. I've never seen this graphic. It was a part of the email. It was like, you know, they knew that we were doing this, and so it's crazy. So I want you to see kind of what country you would be more a part of. Okay, and I think the winner in here is 1.6 is the lowest. Anybody else get 1.6? Okay, 1, 2. No. Did you just go crazy? Yeah, yeah.
I got 4.4. That was my
Well, do you mind just sharing? Can we share? Is that cool? What'd you get?
I deleted mine.
3.9, 2.2,
I feel like
3.
an awful human.
1.6, 3.9, 2.4, 2.5, 2.2, 2.2, 2.3. Oh, 3.3, 3.3. What's that, Emma?
4.4.
4.4,
I'm 2.8.
2.8, 2.4, 2.8, 2.9, 3.4, 3.4, 2.6, 4.3. I'm sorry for laughing. Literally, the quote was, I think I did something wrong because I got 6. No, you just hate the planet, dude. You know. Okay, so you maybe did. I don't know. But you could. I had a girl that took this class a while ago. She was at 9. But she drove every day from school from Huntington. So she drove from Huntington every single day. And then she also took a lot of trips. If you notice, if you want to jack your earths up, like fly, you know, more than once a year. Okay. The flying is a killer. Okay. And for you know, or it'll help you get more earths. And maybe 19 is the highest you can get. I think it's right up there. So US, we're the winners. Okay, in this, Australia 4.1. Okay, you can look at all those other numbers if you want to go a little bit lower. Okay, India, like India is so big. Okay, you know they're like, you know, almost 2 billion people. Yeah, they don't consume that many Earths. China, they're 2 billion people. Okay, they
Yeah, how does China so much better?
once again, they are not consuming as much. They have a lot of people, but we're looking at like the individuals. Okay. So once again, if everyone lived like you live, okay, then we would need that many Earths. These people, okay, are just not consuming that many resources. Okay. You know, and you think about some of those European countries, they have really good public transportation. Right, you know, you go anywhere in Europe, you could just get to all these different countries without flying anywhere. You know, if I want to go to California, I could take the train, but it's going to take like 4 days to get there. You know, and so so it's interesting. On average, 1.6. So you know, or my 1.6ers in here, you're like the world in general, but most of us we would need more Earths than it would be possible to actually do all this, everything that we want to do. Okay. Any questions on that? So this is chapter 1, and that's it. And we will not have a test on chapter 1. Okay, but we will on chapter 2. Okay. So I want to start chapter 2 today, but I want to start with this paper that I'm going to bring out to you, and we're going to do an experiment on Monday, and I'm really pumped about it. Okay. So keep this with you today, but then we're gonna you'll need to bring this on Monday, right?
Okay.
And it's like the same thing on both sides. Why would you do that? Well, hopefully you'll see it. Oops, sorry. Oh, sorry. Oh, got it. Good job on the announcements today.
Me? Thanks, David.
I always make fun of Addie though, because she'd always get on there and she goes, "Hi guys, it's me, Addie."
Trina's on the mountain too.
Were you on the announcements today? Were you the one that were saying, "Oh my gosh, great job.
Thanks.
I love it. I love it."
I just
You're
gotta
talking-
get more of a chill with what I'm
You
saying.
know who that was?
You know what I'm saying, you know?
What's that?
I just gotta get chill and say it, you know?
Okay.
Gina let her write it down. for me.
Yeah. Hey, Mags, I'm gonna put this. I'm gonna email this to you right now. Okay.
Yeah, it kills your brain cells.
I did like a full blown 3 balloons. And I was like, and I seen this one. Like the last year. Yeah. If you do it too much, it's like it takes the oxygen. You're not even getting oxygen.
It's fun though.
Remember that? Oh, yeah, that France. This is hilarious. They sounded like one of the
All righty. So here's what I want to do is I want to take a look at this data sheet and I want to make some predictions. So put your what's that?
The sand.
The sand? What about the sand?
Yeah, I see the sand.
Oh yeah, sure. We can see the sand. So put your name on this, and then at the top next to name, and then next to name put predictions. Predictions. Sand is looking still kind of moist, still kind of wet.
Is there any dry?
There, it is. It is. It doesn't look very dry to me. You want to touch it? See if it's still wet. Huh? Still kind of wet. Still wet. It's like- So there we go. Still wet, but remember there was a little skim of water on the top of that. So no water on the top. Hallie has confirmed that it is wet. Okay.
I think you said keep it till Monday.
You see everyone else in the room has the paper out.
Your word said keep it till Monday.
I know, but you're gonna bring it up on day, but I didn't say put it away.
Well, that was what I thought.
Okay, that's all right. Okay, so I'm pumped about this experiment. Okay, and does anybody have a latex allergy in here? Any latex allergies? Okay, good. Okay, all right. What's that? We'll find out. All right, so we're gonna be putting gas into these balloons on Monday. Okay, and it's gonna unfortunately, like, we don't have enough time that everyone's gonna get a balloon, everybody's gonna get to do like the whole thing. So it's gonna be kind of a little bit of a big group project. Okay, and so how we're going to do this is we're going to look at several different substances and or several different locations, but all the same substance. We're looking at carbon, basically. So I blew this balloon up on yesterday, right after the end of the day, and I used a twist tie to tie the balloon off. So I've not tied this balloon at all. Okay, right? Okay, and then I put another twist tie on the bottom of the balloon that's holding the straw in place. Y'all with me on this? So 2 twist ties, okay? One here that's holding the air in the balloon, okay? And one that's holding the straw to the balloon. Y'all with me on this? Okay? Maggie, can you see it okay? You getting it? All right. So what we're gonna do is we are going to use this solution. Hold on a second. It's called bromothymol blue. Bromothymol blue. This is, and I did this for the first time last year. It was pretty cool. So this is blue, okay? And then eventually, I must not have sealed this very tight because I was going to use the leftovers from last year. But notice that's not blue, so I can't use this anymore, okay? Because some carbon got in here and it changed the color of the blue, okay? So I was kind of bummed, but then thank you, Amazon. $12, bought this 2 days ago and came to my door, okay? So what we're going to do is we are going to have, okay, basically 4 different balloons, okay? I don't know if we will actually use these colors. I think I have the right colors, but if not, we'll figure it out, okay? So we are going to go outside on Monday, and we are going to hook the balloon, one of these balloons, up to my car exhaust, okay? I have a little funnel that goes from my car exhaust. I will start the car, and we will fill the balloon up, okay? What's that? Yeah. Okay, and then it's amazing though. Like when I did it last year, I was like, oh man, this just isn't working. This stinks. And then there it went. It was crazy. Okay, so we got car exhaust. Okay, so we'll tie this off. Okay, and then we will come back in. We'll use human breath. Okay, I will probably do the human breath because of the COVIDs. Okay, then we're going to do pure CO2. Okay, so we're going to get some pure CO2, and then we're going to do a balloon from an air pump. Okay, so we're going to try to do all of these things. Okay, and we are going to determine, okay, which one of these things has the lower pH. Okay, and we're doing this now because our next chapter is about the chemical stuff, okay? So what I want you to do is look at the bottom, and you can see that the least amount of CO2 is going to be a blue color, okay? The highest amount of CO2 is going to be the yellow color, okay? And there's everything in between, okay? So the colors are greenish blue, bluish green, green, yellowish green, greenish yellow, or yellow, okay? So what do you think, okay, is going to happen, or like how does pH change when we talk about CO2? Well, first of all, do you guys know, like, what's the numbers with pH? 0 to 14. Okay, fantastic. Jenna taught you well. Okay, 0 to 14 is the pH, right? Okay, what's the neutral? 7. Okay, so right in the middle. Okay, so like distilled water, that's 7. Okay, if I'm going to be acidic, what's my number range? Yeah. So like 0 to 6.9, right, is like the acidic, right? So everything above 7 is going to be basic, right? Okay, so pH is based, of course, on powers of 10, right? Okay, so when I go from 2 to 3, 3 is 10 times more basic than 2. And 2 is 10 times more more acidic than 3. Y'all with me on that? If I go to 2 to 4, then that's 100 times more basic or acidic, depending on. Y'all with me on that? It's always based on powers of 10. Okay, that's going to be in your homework, by the way. I have a question about pH, and if you don't I mean, somebody always misses that one. Okay, so I say, how many more times is this acidic? And if it's like 4 to 5, you're like, one more time acidic. You know, like, no, it's based on powers of 10, right? If you're going up, even if you're acidic, you're becoming more basic. So 2 to 3 to 4 to 5 is becoming more basic. Y'all with me on that? Even though they're still acids. 4 to 3 to 2 is becoming more acidic. Y'all with me on that? If I'm like 14 to 13 and 12, that's becoming more acidic, even though it's basic. Y'all with me on that? Okay, so what do you think CO2 does to pH of substances? Yeah, does. Makes it more acidic. Okay, big time. Okay, and we're seeing big time trouble somewhere in the world. What's becoming more acidic thanks to the carbon? Yeah, what kind of water? Fresh water, could, yeah, sure. We're not seeing a huge big problem there because fresh water is kind of small bodies of water. What bodies of water might be absorbing? The oceans, right? Okay, so what? Oceans are like becoming more acidic. They're basic right now. It's just becoming a little less basic, right? What would be the problem of having an acidic ocean? What's that? Doesn't kill everything, but it's definitely killing something. Corals. Okay? Okay, because coral is made up of what? What's coral made up of? You guys know what coral is?
Yeah,
We'll talk more about it. Okay, yeah. There's these like living creatures, but then there's like when the living creatures die, like there's like a skeleton, right? That's made of that calcium carbonate. Calcium carbonate and acid, they don't like each other. Okay, so we'll look more at corals. You don't have to like write that stuff down, but just we'll talk about. They're really cool. Zooxanthellae are the living creatures of coral. Okay, so right now I'll give you another second here. So these are your prediction page. What color do you think the control is going to be? The auto exhaust, the human breath, the pure CO2, and the air from the pump. Okay, just write down what color do you think? So the least amount of CO2 is blue, so more basic. The most CO2, more acidic. Bromo, thymol, blue. It's a cool indicator. It's hard. It's not like hard to find, but I'd never used it before until I found out about this. Did anybody use this before? This indicator, this pH indicator. It's really neat.
So these are predictions.
Because wastewater is basic.
So, of course, I have a very limited supply of this, so I'm not going to do this right now. But on Monday, so we'll put the liquid in there, right? We'll put the straw in there, and then we will just, well, sorry, I should do this so Max can see it. Okay, then we'll just basically take this little guy right here, untwist it. Maybe. How did I get it going? There we go. Untwist that and then watch it go and hopefully change. Voila. Yo.
So your bar wasn't red. That's not like a color.
Yeah, man. Like it looks like, okay, so if I think to me it looks kind of more here, I'll pour it out into this. I think it looks kind of like a more orangish yellow when it's out of the bottle.
No, that looks
You
like
think it's
your
red? I think it looks kind of more orangey. Orangey.
You think it's good to drink?
I don't know about that, man.
That's the acidity of that.
Test. Well, I could test the acidity of that right now. You want to see?
Yeah.
Let's see what it is. Looks like it is about fiber. Fiber
What's the acidity of your tea?
can change. Okay, remember we did. Oh, you're gonna find out because hey, confirm this for me for Justice and those people who took anatomy last year. Okay, we do a urinalysis in there, right? Huh? Oh yeah, that's right. You didn't get to do it. Crap.
We left before we were going to do it.
Oh man. Yeah, people are freaking out right now. They're all like, "Can you please give us a month notice? Because we're gonna test for lots of fun stuff." Okay, but pH is one of them, man. pH is one of them. So it changes with whatever you eat. But typically, I think normal. I'm just blanking on this right now. I have a chart here in analysis. I'll just Google it. Normal pH urine. Let's see, 6 to 7.5. What? Is that over? Crap. See ya. Fun. Thanks for joining me, Max. We'll do this on Monday. Bring your check thing on Monday. Hi. See ya. What are you doing there, girl?